Hi everyone, and welcome to Expressions and Equations Lesson C, Topic 2, Solving Two-Step Equations. In this video, we are going to learn how to apply inverse operations to isolate the variable and solve two-step linear equations involving integers, fractions, and decimals. We are also going to learn how to evaluate the equation by substituting the value of the variable to check if the solution is correct. Let's get started. Solving two-step equations with inverse operations. What is a two-step equation? Well, a two-step equation is an equation where two operations are performed on the variable. The goal of solving any equation is to isolate the variable. The steps to solve are to first look at the constant term. Use the inverse of addition or subtraction. Then look at the variable term. Use the inverse of multiplication or division to get the variable alone. Remember to keep both sides balanced, so what you do to one side, you need to do to the other. Let's practice. So this is what a two-step equation looks like. One example anyway. Negative 3x plus 4 equals 25. We need to remember our steps. Remember to look at the side that the variable is on, and to first look at the constant. We have a positive 4 or a plus 4. We need to undo this constant term with the inverse of addition. The inverse of addition is subtraction, so we are going to minus 4 from both sides of the equation. When we minus 4 from both sides of the equation, we end up with negative 3x equals 21. The next step is to look at the variable term. We have a coefficient with our variable. Coefficients mean to multiply. So we need to undo this variable term with the inverse of multiplication, which is division. So we are going to divide both sides by negative 3, that coefficient, to get x by itself. When we divide both sides by negative 3, we end up with 1x, or just x, equals negative 7. Please remember to pay attention to your integer rules and your signs. 21 divided by negative 3, a positive divided by a negative, should give you a negative 7. But don't forget, we need to check our answer. So our original equation was negative 3x plus 4 equals 25. We will check our answer with substitution by taking the negative 7 and plugging it in to the x in the equation above. So now we will have negative 3 times negative 7 plus 4 equals 25. Negative 3 times negative 7 is positive 21, plus 4 equals 25. So 21 plus 4 actually is 25, and that equals 25, so we know that we are correct. Next one. Ooh, fraction. Don't let this be scary. I'm going to show you how to make it pretty simple and easy. There's also another way to go about solving this problem. There's a few ways to go about solving this problem. However, this way is just the way that is the fastest way as far as the steps go. So this is the two-step version of 2/3 x plus 12 equals negative 20. So we have a fractional coefficient plus 12 as a constant, and that's all equal to negative 20. So first things first, remember your steps. First, we are going to undo the constant term. So the constant term here is plus 12. So to undo that plus 12, we need to minus 12 from both sides. When we minus 12 from both sides, we end up with 2/3 x equals negative 20 minus 12 is negative 32. Now, we're still focused on the side with the variable because our goal is to get it by itself. And we have this fractional coefficient. And we need to undo this fractional coefficient with somehow with division or multiplication, right? Because it's fractional. Does a fractional coefficient mean to divide or multiply? Well, I don't want you to get too tripped up on that because remember, we can honestly, dividing by a fraction is the same thing as multiplying by the reciprocal. So that's what we're going to do. If you have a fractional coefficient like 2/3 or 3/5, but in this case it's 2/3, you are going to multiply by the reciprocal. The reciprocal, remember, is the flipped version of the fraction. So 2/3 times 3/2, that will actually cancel out to give you 1x. Now remember, what you do to one side, you need to do to the other. So negative 32 times 3/2. Guys, remember this is like negative 32 over 1. And in order to multiply fractions is easiest. Most people like multiplying fractions the most because you can just multiply straight across top and bottom. So we'll have 1x equals negative 32 times 3/2. Negative 32 times 3 up top is going to be negative 96. And then don't forget, it's going to have to be divided by 2. So negative 96 divided by 2 is actually negative 48. So let's check this. Are we correct? Because, that was a fraction, right? Well, we had 2/3 x plus 12 equals negative 20. So let's plug our solution in to x. 2/3 of negative 48 plus 12 equals negative 20. So you can multiply this straight across top and bottom and divide. But what I do is I look to see if this number is divisible by the denominator of the fraction that I'm multiplying by. If this number is divisible by the number that I am multiplying by, then I can easily just say, hey, how many times does 3 go into negative 48? 3 goes into negative 48 16 times. So 16 times that positive 2 is actually going to be negative 32 plus 12. So negative 32 equals negative 20. So negative 32 plus 12, hey, that's actually negative 20. So negative 20 equals negative 20, and we are correct. The answer is negative 48. Let's look at the next example. X divided by 2 minus 7 equals 10. Don't forget to remember your steps. The first step is to undo the constant. So we're going to look at the constant that we have on the same side of the variable, and the constant that we have on the same side of the variable is negative 7. So we're going to undo that negative 7 with the inverse of subtraction, which is addition, by adding 7 to both sides. When we add 7 to both sides, we end up with x over 2 equals 17. Now we look at what is with our variable. We have a fraction with as x divided by 2. If you remember from the one-step equations, anytime you see a fraction like this, when the x is in the numerator and we have a denominator, this is division. And we need to undo the division with multiplication. So we are going to multiply both sides by 2. When we multiply both sides by 2, the 2's cancel out over here, and we end up with x equals 17 times 2, which is 34. We're not done yet. We have to check our answer. So our original equation was x divided by 2 minus 7 equals 10. If we were to substitute our solution into this equation, we would have 34 divided by 2 minus 7 equals 10. Remember PEMDAS that we should do 34 divided by 2 first, which is 17 minus 7 equals 10. 17 minus 7 does equal 10. So 10 equals 10, and we are correct. (17) equals negative 8 plus 2.5. Ooh, we have a decimal, but we're not going to let that scare us because we know how to work with decimals. The first thing is to remember your steps. I know we're used to seeing the variables over here, but this time the variable is on this side. So we're looking at the constant on this side with the variable. So in this case, we see a plus, but the constant's a negative 8. So we need to undo the constant term, not just assume, oh, we see an addition sign, so we need to minus. No, we are looking at what our constant, the value of our constant is actually negative 8, and that plus sign indicates that we have a positive coefficient. So in this case, we're going to actually add 8 to both sides of the equation. When we add 8 to both sides of the equation, it zeroes out on the side with the variable, and 17 plus 8 on the other side is equal to 25. So we end up with 25 equals 2.5x. Then we will undo the variable term. So we're looking at the variable term and we see a coefficient. Coefficients mean to multiply, so we must undo this with division. So we're going to divide both sides by 2.5. When we divide both sides by 2.5, of course the variable term turns into 1x because that's the goal. And 25 divided by 2.5 is 10. Last but not least, check your answer. Your original equation was 17 equals negative 8 plus 2.5x. If we substitute the 10 in for the x, we end up with 17 equals negative 8 plus 2.5 times 10, which is 17 equals negative 8 plus 25. And negative 8 plus 25 is indeed 17. So 17 equals 17. 1.2x minus 3.1 equals 4.7. Ooh, all decimals. But we're not going to let that scare us. We're going to remember our steps. The first step is to undo the constant term. So the constant term on the same side of the variable is a negative 3.1. So we need to undo that negative by adding 3.1 to both sides. When we add 3.1 to both sides, we end up with 1.2x equals 7.8. The next step is to look at what's going on with the variable term. It looks like we have a coefficient. And when we have coefficients, that means multiply. So in order to undo the multiplication, we must divide both sides by that coefficient of 1.2. So 1.2 divided by 1.2 is 1, so that makes that a 1x. And 7.8 divided by 1.2 is 6.5. Let's check our work. 1.2x minus 3.1 equals 4.7. Let's substitute. 1.2 times 6.5 minus 3.1 equals 4.7. Well, 1.2 times 6.5 is 7.8, and 7.8 minus 3.1, well, that is 4.7 equals 4.7. We are correct. So remember to always check your answer. Thank you so much for watching this video.